Today we're going to take a look at how to find inverse functions. So we're going to learn how to find the inverse of a function algebraically and graphically. Just so you know, in order for it to be a function, it has to be a one-to-one function. So when we're finding the inverse of a function, we're only doing those for functions that are one-to-one. Remember, one-to-one means that every y value only has one x value. And then we're also going to determine whether two functions are inverses by applying composition. So we're going to prove that they're inverses by taking the composition of them. So the inverse of a function has this symbol, f, and then in the exponent is -1. So this is called f inverse, or the inverse of f, or so f inverse, the inverse of f. So it's going to be a relation, and it's going to be a relation where the coordinates are switched. So you're going to switch your first coordinate and your second coordinate, and so your x becomes your y and your y becomes your x. So if this is our f function here, in order to get our inverse of f, we're going to switch our coordinates. So instead of saying 3, 5, we're going to say 5, 3. Instead of saying 9, we get 9, 2. And so on. So to find the inverse of a function, if you have a function that's listed as ordered pairs, you just change x and y. If you have a function rule, to get the inverse of a function, first of all, if they have f of x, go ahead and change f of x to y. And then once you've done that, switch the y and the x. So interchange the variables. So that's step 1. So change x and y. Swap them around. And once you've done that, solve for y. And then once you solve for y, if you still have a function, then you can, instead of saying f of x, now you can use the -1. So f inverse of x. So you have f inverse of x instead of f of x. So let's do an example. We want to find the inverse of f of x equals 5x minus 7. So first, we're going to replace the f of x with y. And once we've done that, we're going to interchange x and y. So instead of saying y, we're going to say x. Instead of saying x, we're going to say y. Now that we've done that, we want to solve for y. So I'm going to add 7 to both sides, and then I'll divide both sides by 5. And then I'm going to look at this. I'm going to look at y equals x plus 7 divided by y. I know that's linear because it has the power of 1, so I'm going to go ahead and write it into mx plus b form. So I get 1/5 x plus 7/5, and that's a function. So I'm going to replace the y with f inverse, or f to the -1 of x. So this is f, instead of f of x, and I have f inverse of x. So let's take a look at those two graphs. This is the graph of f of x, and this is the line y equals x. So when we did the inverse of f, you'll notice that we get this line, f inverse, and notice how our original function and our inverse function, those are just reflections across the line y equals x. So if you're wanting to find the graph of an inverse function, all you have to do is reflect it across the line y equals x. All right, so let's try to prove that our inverse, f of inverse x, is x plus 7 divided by 5. Let's try to prove that that's the inverse of 5x minus 7. So to prove that's the inverse, we're going to do f composed with f inverse. So we're going to take our inverse, and we're going to substitute it for x in our f of x. So instead of saying 5x minus 7, I'm going to say 5 f inverse minus 7. So 5 times f inverse is x plus 7 divided by 5. So again, instead of saying 5x minus 7, I said 5 times f inverse. And f inverse is x plus 7 divided by 5. So my 5 cancels. I'm left with x plus 7, and then the minus 7. So I end up with x. So as long as I get x whenever I compose f and f inverse, as long as I get x, that proves that those are inverses of each other. All right, so one more thing. I want to do an example of graphing the inverse given just the graph of another inverse, or graph of our original function. So I'm going to take the line y equals x, which is right here, and then I'm going to reflect my function across that to get my f inverse. And that's all. Go ahead and try some problems on your own.